Hello and welcome back. In this video, we'll take a closer look at the Pandas library and have a first introduction on what we can do with this. This is a very powerful library and we can only scratch the surface in this little exercise, but it's one of the standard library that we will come across when you work as a data scientist. Pandas is used for structured data, so all the data that can either be in the form of a table or that can be represented as a time series. As with other modules, there's a commonly used abbreviations, and we typically use PD for pandas. So NumPy was NP, Matplotlib was PLT, for example, and pandas is PD. So whenever you come across in other people's code in these abbreviations, you can almost certainly expect that they use these libraries. The most important concept of pandas is called a data frame, and this is essentially what is, for example, a table or a workbook in Excel. It's a representation of structured data, and many packages use the pandas data frame as the underlying format that is used to exchange data. And this is another reason why pandas is so popular and so important, because it is used to sort of shuffle data across from different packages, and it is used for different purposes in these packages. But the data frame is the underlying mechanism that is used to move the data about. In the following, we use a very simple data set, the iris data set. It's a very simple training data set that demonstrates a lot of data science approaches, and it contains data about 3 different types of the iris flower, the setosa, versicolor, and the virginica. It was originally introduced by Sir Robert Fisher in 1936, of course not in Pandas, and it contains only 4 features. That means 4 variables, and they're all measured in centimeters: the length and width of the sepal and the length and width of the petal. These data are often included as demo data sets, and it's also publicly available in various repositories, where we also got this from, and there's also a copy in Seaborn because it's so popular. We don't really want to focus on how to build a machine learning model with this, but we want to explore how we can use Pandas and Seaborn to visualize the data. And this is one of the typical things you will need to do as a data scientist. When you start, you have some data, you look at the data and try to figure out what it means, and also to get some understanding of maybe what relationships between the data look like, and also where some problems might be. So the data looks like this. We have the first row describes what's in it, and then we have in each row the values of the variables and the label that is the true assignment. Notice here that we have an index that just gives the number of the row. So the first column without a name, because we just have a comma here, is the running index, and we have the 4 feature variables, and then we have the label that is the final variable with the true assignment. These data are stored in the common CSV format for comma-separated values. This is a very common data format that is often used in data science and other applications, and it's suitable for small structured data. If we had larger files, we would typically use other formats, for example, like Apache Parquet or HDF files or others. So the first step, we first need to read in the contents of the file and store the data in the data frame. Then we can work with this. As we first mentioned, when we're working with files in Python, we really rely on a lot of libraries to handle these specialized formats. And Pandas knows how to read CSV files, so we don't implement the functionality ourselves. So we import Pandas as PD and Matplotlib and Seaborn because we want to visualize the data later on. And then we read the file with this read CSV, give it the file name, say that the first column is the index, right? So this is the running number here, and the return value is the data frame, and we assign it to a variable. We can then print the first few lines of this new data frame to see the structure, and we can see that the presentation from the file we have here in this data frame is pretty much the same, and Pandas displays this neatly as a table. This is one of the key features of structured data, that we can represent it as a table. Now, the first task as a data scientist would be to explore the data, and one of the most fundamental steps we can take at the beginning is to look at frequency plots. These are called histograms. So we can see, for example, how often a specific value occurs. So for illustration, we only use two variables and plots next to each other. That means that the axis in which we interact with the plot is no longer a single variable, but now an array, right? So we have axis 0 and axis 1, as we can see. So we have two columns, left and right, or 0 and 1. And then we put one plot to the left and one plot to the right. And we take the separ length and the petar length, and then we get a distribution of these two variables. The count indicates that this is a frequency histogram, and we see that the value of 5 occurs a little bit more than 20 times. Note that Seaborn knows, because we do a hist plot, that this is a frequency plot, and it already gives useful labels to the axis, so we don't have to do anything like this. Manually, we could, of course, override it ourselves if we wanted to. Now, in order to understand the relationship between these features, we want to understand how this depends on the type of the iris flower. So we can color code this, and the hue is now given by the label, the species. We only look at one variable, otherwise it gets too confusing. And we look at the same. We put in the data from the data frame, say the variable we want to investigate is, for example, the sepal length, and then the color is defined by the species. And we can see that the sepal length is quite distinct for the different types of flowers. So the setosa is mainly here and has a very small length. The virginica has rather large length, and the versicolor is in the middle, but it's not clear-cut, they all overlap. We may also want to know how two variables behave when we compare them to each other. This is done with a scatter plot, where we plot each data point from two variables, and we scatter this, and hence the name, in 2 dimensions. You can also use rel plot for the same effect, but it has different options, and you can investigate how this works. If we have a large data set, we can use hisplot again, and pass two variables, x and y. This then looks like a scatter plot in the sense that we have the whole data not as individual points, as we do now with the scatter plot, but with little boxes for the histogram. But now this data set is very small, so we use a scatter plot. So on the x-axis we have the sepal length, and on y we have the sepal width. And as color, we use the species again. And this is what's called exploratory data analysis. We see these two variables, and we see that they behave quite differently when we look at the species. For example, we can see if we were to draw a line around here, we can capture almost all setosa flowers compared to the others. So this one is easily distinguished between the others, whereas the versicolor and virginica, the orange and green dots here, are not so easy to distinguish. We may now want to look at all combinations, so we could do the same plot again several times, or Seaborn provides us with a convenience function for this, which is called pair plot. So if we call this, we get the same thing, and on the diagonal we get the histograms, as we've done manually before, and then we get all combinations of all variables. Obviously, if we have a lot of variables, this becomes less useful. We need to define a subset of variables we want to look at.